Welcome everyone. Hope everyone's having a good day today. My name is Mark Zingari. I'm the specification manager at EQUITONE in Australia. So welcome to our building ventilated facades with fibre cement webinar today. So what I'm going to do is I'm going to share my screen. And feel free to ask any questions. We have got my colleagues as well who will be able to assist you with any questions you might have. So feel free to type them in the chat box. But we'll make a start on the presentation. So hopefully everyone can see the presentation on the screen at the moment. If you can't, feel free to let me know. What we're going to be looking at today is we're going to be looking at developing a deeper understanding of fibre cement and its history. We also want to understand the evolution of fibre cement as a facade. We want to look at the characteristics of a through colour fibre cement material. So just how this is different from a painted material. We also want to learn about ventilated facades and their features. Discover the design possibilities of fibre cement facades today. So we'll have a look at some projects all around the world and just see what the through colour fibre cement added to those projects. And also, finally, who is EQUITONE? So my background comes from experience within fibre cement. So I've worked for two large fibre cement manufacturers in Australia, being James Hardie and CSR as well. And more recently with waterproofing with a company called Ardex in Australia as well. So I understand fibre cement really well, and also the weatherproofing component very well as well, and understand how they work together in order to ensure that the ventilated facade is maintained, but the building remains free from any water getting into the building itself. So the evolution of fibre cement facades. So it's a very strange image to be starting off a fibre cement presentation with. So the year was 1903, and the Wright brothers took flight with the Kitty Hawk in North Carolina. So what does this have to do with fibre cement? We asked this question throughout our presentations, and I'm sure a lot of you are probably thinking it's got to do with the wings, because that's the answer that we always get. But the clue is in the year. So not so much the image, but in the year. So in 1903, this famous event took place, but it was also the same year that fibre cement was invented. So fibre cement was invented in 1903 by the gentleman on the left, Ludwig Hatschek. So Ludwig Hatschek lived in Austria and was the son of a rich brewery owner. He had an old cardboard company that stopped working because of the lack of wood fibres at the time. So what Ludwig wanted to do was experiment with a new material. So he wanted something to replace wood, something that was lighter than brick, cheaper than slate, and better than sheet metal. So Ludwig invented the fibre cement material in 1903. In 1905, the gentleman on the right-hand side, Alphonse Emsens, bought the patent off Ludwig and started manufacturing Eternit to be supplied around the world. So in relation to the ETEX group, which EQUITONE is a part of the ETEX group, there's still a close tie to the Emsens family who sit on the board of the ETEX group up until today. So what does fibre cement consist of? So we have got cement, sand, water, and air. So the cement, sand, water, and air are the core ingredients. And then you've got the reinforced fibres. So the reinforced fibres are cellulose fibres, which come from trees. And it's really important in terms of binding all the ingredients together and also adding strength to the panel. So it's a key component to what makes up fibre cement. In the past, you had asbestos fibres, which has sort of been widespread throughout the world. And those were replaced with cellulose fibres from all manufacturers. Some manufacturers had different dates, but the reinforced fibres from cellulose from trees are what's used in fibre cement. So this is the Hatchek machine, it's called. So this is what manufactures fibre cement. So named after the inventor of fibre cement, Ludwig Hatchek. You can see there that the fibre cement manufacturing is based off principles of cardboard company manufacturing, or cardboard manufacturing, which is what Ludwig owned initially, was that cardboard company. So you can see there in terms of the bottom, you can see the highlight, the grey bubbling areas in the silos, which contain all the mixture that we just spoke about, the sand, cement, cellulose fibre, water. And what happens is that gets transported to your drum on your left-hand side. So you can see the drum creating in different layers. So depending on how thick that fibre cement is being manufactured will determine how many layers get made up from that big drum. So once that's created, it's then cut off and then taken to cure and also to be compressed. Now, EQUITONE differs a lot from a lot of other fibre cement throughout the world in that our panels are deemed high density. So a lot of panels will be either medium density or would be classified as compressed. We're actually one step further. So we place greater compression during manufacturing in order to make it highly dense, or high density panel. What that means for your project is that it contains better impact resistance, being a high density material as well. Also as well, it closes a lot of the pores within the fibre cement itself. So the high density material is really, really important in terms of having something which is long lasting and durable. So this is the Hatchek machine, which is in our German plant. As you can see there, the bottom, those three areas, or the three silos down the bottom. And then you can see the belt, which takes the material up. And then you can see the drum on the left-hand side as well. So fibre cement's a really good option for external applications. In Australia, fibre cement is deemed non-combustible, which means that it can be used in all areas or all facades where you need a material which isn't going to combust, I guess is the nature of it, but can be used in all buildings in Australia without any issue. It doesn't need to be tested. It's deemed as non-combustible. So that means it's a really good option for external applications. So what we're going to be talking about predominantly today is architectural facades. But you've also got flat sheets, which are used in a lot of eaves linings and soffit linings in Australia. Also used as house cladding as well. So a lot of houses are clad with the flat sheets. And you've got the corrugated sheets and the slates, which are used predominantly for roofing in Europe. And then you've got the decking panels as well. So through our sister company, Seadrill, they manufacture fibre cement decking. You can see through the image at the top there. And fibre cement serves just as well for internal applications as well. So in Australia, we use it quite a lot in wet areas, so in bathroom areas. Fibre cement's used to line the walls and sometimes the floors before waterproofing and tiling occurs in bathroom areas and wet areas. We use it quite often as acoustic panels as well. So when we do a lot of school projects, or we do a lot of leisure centre or pool complexes in Australia, fibre cement's used for acoustic panels. Through our sister company, Promat, who you may or may not have heard of, they do the fire protection for fibre cement as well. And then you've got things like partitions, window seals, and also ceilings as well, which fibre cement can be used. So in Australia, it's deemed as a Group 1, which is the best performing for internal applications. So in 1954, Willie Gould created the loop chair. So this is made out of fibre cement. So basically, I guess how we're used to seeing fibre cement in the industry is a flat sheet. How this was made was that when the fibre cement came out of production, it was shaped to achieve that loop chair and loop table design. So what Willie saw was that the material was thin and light, but also strong and flexible enough to create pieces like this. So this is actually a functioning chair. So you know, you can actually sit in it, and it'll take weight and things like that as well. And I believe they're still selling it up until this day as well. In 1952, Le Corbusier used fibre cement for the first time in a facade. So this was in a social housing project in Marseille. The goal was to improve people's living conditions by bringing character to the building. So the fibre cement you can see here is in the dividing wall. So you can see the colourful red, brown, yellow, blue dividing walls. This was the intent, to use the fibre cement to improve people's living conditions through this project here. So then it was also the first year back in 1952 of fibre cement being used in a facade application. Now we move on to 1955, and EQUITONE, which is now the ETEX group, which EQUITONE is part of, started manufacturing fibre cement to be used as outdoor facade cladding. So before this, it was more confined to use in industrial areas or industrial use. But then the EQUITONE started manufacturing those larger panels to be used as a ventilated facade. What this meant is it just allowed the designers more freedom of design as well, and also just allowing more creativity of how the building should look. In 1960, Walter Gropius used fibre cement in the project Gropiusstadt. So here is the funny thing about this project here was Walter's original view or original design of Gropiusstadt was to be something which was low rise and spaced out. As you can see from the building, it definitely isn't low rise and spaced out. The reason being is that the construction of the Berlin Wall happened at the same time. So it restricted the area that they had to work with for this project. So they had to build up. Which is, you can see here, the high rises in this Gropiusstadt project as well. In terms of this, it was used to accommodate the project requirements with the limited space available, but it also helped Walter establish himself as one of the pioneers of modernist architecture, and also in ventilated facades as well. In 1987, the project here by Herzog and de Meuron was the Ricola factory warehouse in Switzerland. So I'm not sure if you've had Ricola before, and you know, I might be showing my age here, but I can just remember the old flip-top boxes or flip-top lids of the Ricola confectionery. This is what the project had. Its, you know, this is the design that they looked at using, was to recreate that flip-top lid for this Ricola factory warehouse as well. At the same time, it was also a turning point in the manufacturing of fibre cement, because this is the first project, or one of the first projects, where a raw uncoated fibre cement was specified to be used. So manufacturers started to change manufacturing to suit the requirements of the designers as well. So, and this is one of the projects that sort of ensured that that was happening. In 2004, EQUITONE Germany, which is now EQUITONE, launched the Natura. So the Natura was the first through color fibre cement which was launched into the market. So basically, this was, you know, before then, fibre cement would have to be painted, which meant that you'd have to maintain the paint. So by having this high density through color material, it was just keeping the designers and their clients in mind in relation to, there was no need to, you know, paint panels in the future. Also combined with a higher density of the panels, you also had greater durability with a fibre cement facade panel as well. So what are the characteristics of a through color fibre cement? So with a through color fibre cement, there's sort of three things that we're looking at. We're looking at authenticity, tactility, and individuality as well. So you have got different colors, different shapes, which we'll have a look at, different textures, as well, which it means that you can create something authentic, tactile, and individual by using one, two, or even all of the panels in the range together, maybe on the one plane or different planes of the building. But also the through color fiber cement has a long lifespan, and the long lifespan is because of the through color nature of the panel, and also the high density nature of the panel as well. So if I compare this to a painted panel, and we say, for example, we've got an area which is subject to damage, future damage, what will happen is if you damage a painted panel, water can get in behind the paint, start tracking around the panel, and eventually break that panel down over time. Now, with a through color high density fiber cement, this won't happen because you've got the color running through the panel, but you've also got the high density of the nature, means that a lot of the capillaries are closed within the panel itself, so water doesn't have anywhere to track. So you've got greater durability and long lifespan with a through color high density fiber cement. It's also a natural material as well. You have got the design versatility through your different colors, textures, and finishes available. It's deemed non-combustible in Australia. So it can be used in areas subject to not having to test the panel for fire and things like that, because it's deemed non-combustible. Also weather resistance as well. So the weather resistance comes from the ventilated facade that's used to create used to create the wall with EQUITONE, or the facade. You've got minimal maintenance required, so there's no need to paint or seal the panels in future. You know, a lot of panels out there, claim to be minimal maintenance, but when you actually read the maintenance guide, you'll see that you have to check and reseal the panels in the future. This differs with EQUITONE. If you read our maintenance guide, there's no mention to do that. And you've also got variations in macro texture between the panels, which just means that it provides a more natural finish. So, you know, we always get commented on how natural our panels look. There's some panels out there that do look a bit modelly and a bit planned, whereas ours look a lot more natural. So we always get compliments in the aesthetics of the panels themselves. So as mentioned, deemed non-combustible. So for the NCC, which is the National Construction Code of Australia, EQUITONE can be used in areas where there's no testing required for, a fireproof wall and things like that, because the fiber cement itself, or EQUITONE itself, is deemed non-combustible. Fiber cement itself and EQUITONE is a really good option for use in cyclone-prone areas. So in Australia, we've tested it to 7.99 kPa ultimate wind pressure. So we can use this in all areas of Australia. So up north, in the Cairns region and in the Darwin region is cyclone-prone areas in Australia. So EQUITONE is more than sufficient to be used in those areas with the bracing capabilities. A really good option for modular construction. So this is the Hong Kong Museum of Art, which is all prefabricated as well. So we're seeing a real push for prefabrication in Australia at the moment, especially with our education projects. And fiber cement and EQUITONE as well is a really good option to use in this situation of prefabrication. There's also a project in Holland as well, which they created a wind tunnel, and it was all prefabricated as well. So, construction is going down this way because, safety becomes a lot more paramount on building sites. So if you can take a lot of the stuff off-site to construct, it makes sense to do that. In terms of sustainability, EQUITONE really has a really good message in relation to that, through not only what we're doing at the moment and our goals to 2030. So if you get a chance, have a look on the sustainability section of the website and you'll see our goals to 2030. But the panel themselves have low maintenance costs. So not only does it have a low maintenance cost in terms of dollars, but also in terms of sustainability. And the way that is because if you think about a painted panel, you know, the panel might need repainting in 5 or 10 years' time. So someone's going to get in their car, get in their truck, drive to site, possibly set up scaffolding just to repaint the building. So if you think about how much that sort of takes its toll on the environment, that's eliminated with the use of a low maintenance panel. EQUITONE is also used as a reusable facade. So on that sustainability section of the EQUITONE website, you'll see a project in Germany where it's the first case of reusable EQUITONE, which is used on that project. So I believe all the components of that building, which is a residential building, are recycled, even the panels. So it can be reusable in that sense. But the material can also be recyclable as well. So at the end of its service life, the EQUITONE can actually be crushed up and used as gravel in landscaping applications, you know, garden applications as well. In their production facilities as well in Belgium and Germany, there's production recycling. So all the raw ingredients don't get wasted. So any offcuts or anything like that gets placed back into production. Also the durability as well just means that you're not having to change your facade because of damage in the future as well. So the durability factor definitely adds to the sustainability of the panels themselves. And also the installation as well in terms of creating that ventilated facade. So creating that ventilated facade just means that you're not as reliant on your heating and cooling of the building, because your ventilated facade helps a lot with your heating and cooling of the building itself. So in terms of ventilated facades, we've just got a short video that I will present. What I'll do is I'll just double check that I've turned the sound on, because okay, so that should be on now. If you can't hear it, please let me know.
The ETEX group of companies provides a comprehensive range of facade claddings to fit all shapes and sizes of buildings. These claddings are used as a rain screen. Rain screen, which is also referred to as a ventilated facade, is a kind of two-stage construction. An inner structure with a protective outer skin. This skin protects the structure against the elements. With the placing of the insulation on the outer face of the structure, rain screen also meets the challenges of modern construction in terms of preventing thermal bridges, dissipating solar gain, reducing thermal movement of the structure, resisting moisture and humidity, preventing internal condensation. By using our panels as the protective outer skin, we also give the buildings the added feature of looking good. Rain screen is ideal for use in both new buildings and renovation projects. The drained and back ventilated technique is the simplest form of rain screen and is favoured in Europe. It consists of a thin impervious flat sheet fixed to a supporting frame which forms a clear cavity between the panels and the insulation. The joints can be open or lightly baffled. The special thing about the drained and back ventilated approach is that the cladding is allowed to leak. Any water that may penetrate the joints and enter the cavity behind the cladding is quickly evaporated through the natural ventilation in the cavity or by draining down the back of the panels and out at the base of the wall. In driving rain conditions, the moisture forms a membrane across the joints, which keeps most rainwater on the outside of the panel. Scientific testing carried out by FVHF from Germany has shown that the amount of driving rain that ever reaches the face of the insulation is minimal. The effectiveness of any rain screen system can be checked by standing at the base of a large installation in the driving rain and observing how little water emerges from behind the rain screen cladding. In addition to the outer skin, a number of other elements need to come together. Starting from the inside, the internal structural wall can be of masonry or lightweight construction. It needs to be airtight and to withstand the wind loads that will be placed on the building. The insulation thick enough to suit the building's function should also be suitable for rain screen use. Ideally, the insulation should be fireproof and permeable to allow any water vapour to pass from inside the building into the cavity. This needs to be securely fixed to the structure and fit tightly around the supporting frame. The supporting frame should be designed to carry the panels and a certain amount of wind loading. This supporting frame is commonly of aluminium, galvanized steel or timber battens. The ventilated cavity should be of adequate size to provide both air movement to evaporate moisture and vapour and a drainage path for water to run down the rear of the panels and out at the bottom of the cladding. Air must be allowed to enter at the base, travel unobstructed up the wall and exit at the top of the building. Now for the physics bit. By placing the insulation on the outer face of the structure results in a number of benefits for the building. Notably, in wintertime it keeps the building warm and the cold air is prevented from affecting the building structure. In summer, the ventilated rain screen has a cooling effect when outside temperatures are high. Most of the sun's rays are reflected away from the building. Heat that passes through the panel is partially dissipated by the ventilating effect in the cavity. An additional benefit in controlling temperature is that the structural movement of the building is minimized. Acoustic performance of the wall is increased when compared to other forms of construction. In conventional construction with internal insulation, the thermal shield has weak spots where the floor meets the wall. These are called thermal or cold bridges. This results in heat loss and can cause surface condensation, which can lead to mold growth. By having the insulation on the outer face of the wall, it can be easily mounted without interruptions. Therefore, any thermal bridges are eliminated. The rain screen system is very efficient in controlling condensation. Any risk of interstitial condensation occurs in the ventilated cavity. The breathable structure allows water vapour to pass through the construction from the inside into the ventilated cavity. All of this results in a greater degree of comfort for the occupants and ensures a healthy building. Climate change is of course a big issue. As you have just seen, rain screen is most suitable in meeting the demands in many climates. The drained and ventilated rain screen that we promote does not need the use of any special sealants and relies on simple techniques to work. Tougher standards and regulations can easily be met with rain screen. Rain screen is adaptable and will meet the needs of any changes in architecture, fashion or construction methods. ETEX has been at the fore of rain screen development for many decades and has built up a vast knowledge. Its panels have been successfully used in many projects in many different climates the world over. We offer cladding solutions to fit all shapes and sizes of buildings that ensure the screen is lightweight, strong, durable, excellent resistance to fire, frost-proof, resistance to fungi and insects, minimal maintenance, and is also aesthetically pleasing. Just because its primary purpose is to serve as a rain screen, there is no reason why it can't look good too.
Yeah, so for a recap on the video, your ventilated facade build-up, you have got your insulated weather-tight backing wall. So this could be either masonry or framing. Then you've got your air cavity. So your air cavity is vertical to allow ventilation up and out the top of the wall. So your air cavity is created by your adjustable sub-bracket framing. And then you've got your outer material, which is your cladding. So in this situation here, it's the EQUITONE as well. So what does this mean for the building? Is you've got something which prevents thermal bridges. So in this image, you can see on the right-hand side, your wall and floor junction with traditional insulation in the cavity, your wall and floor junction would be a weak point because there'd be no insulation in that area. By having the insulation on the outside wall traveling all the way up, it stops that thermal bridge from happening. So there's no path for the thermal heat to travel between inside and outside and vice versa as well. Dissipate solar gain. So you've got your two factors. You've got your primary factor and your secondary factor. So as the solar gain tries to enter into the building, you have got your ventilation in the cavity, which is your primary factor for dissipating that solar gain. And then you've also got your insulation on the outside wall, which is your secondary factor to dissipate your solar gain as well. So that just ensures that you in summertime, you're not using the cooling as much as you would because you have got that wall performing very well. Reduces thermal movement in the structure. Basically, with the thermal movement, it is caused by the expansion and contraction of the building fabric due to hot and cold weather. So the insulation and the ventilation on the outside of the building acts as a jacket to the building itself, so it provides a much more stable temperature on the inside of that. So things like your internal, linings, there's less stress placed on them for expansion and contraction. So it provides a much more stable temperature. Provides a dry, healthy cavity, and this is through the ventilation drying out the cavity. So Australia, we've just had the last year, which we've had a lot of rain, more than quite. I think we had the La Nina in Australia over the last year, and a lot of people sort of seen the mold, which was forming in their walls. You could basically smell it because of all the rain that was happening. Sorry. So the ventilation through the ventilation through the ventilated facade dries any moisture in the cavity, so that moisture doesn't turn into mold. So it provides a nice, healthy cavity for the wall. Also, so aesthetics. So the insulation and the ventilation allows you to use darker panels on the outside of the buildings because you have got that, that solar gain from dissipating the building as well. So although it's going to attract a lot more heat with a darker panel allowance, you have got that ventilation and you have got that insulation providing your primary and secondary factor for that solar gain. And you can also hide surfaces in the cavity as well. So you can run things like downpipes through your ventilated facade. Maintenance as well. Sorry. So with maintenance, there's less reliance on exposed caulking and sealants. So in Australia, I guess the other option, if you don't do a maintenance facade, is called a sealed facade. So with a sealed facade, you need to use silicone sealant or caulking around the panels to ensure that they're trying to stop water from getting into the facade. So there's no allowance for drying. They're trying to stop water in. What happens there is that your silicone sealant, your caulking does need to be maintained. So, it does need to be, it will get brittle over time and fail. So it does need to be maintained. With a ventilated facade, there's no reliance at all on that exposed caulking and sealant to perform. And also you've got the maintenance of the weather tightness of the building over its surface life as well. So if we have a look at the design possibilities of fibre cement facades today, we'll have a look at some projects and just see how EQUITONE benefited the project. So the first one is the Earl Opera House in Austria. So you can see there that it does look quite intricate. Even though it does look quite intricate, there was only two shapes used on the whole building, and you can see there they've used it back to back. Now, due to EQUITONE's through color nature and high density nature of the panels, you can actually get some sharp cuts, as you can see in those patterns, with the panels themselves. So you can, have different shapes within the building as well in order to shape the building. Where you've got high wind areas as well, EQUITONE is really good for that because of the high density nature of the panel. It can be used in high rise and high wind areas here. So this project in Holland, you can see there that the wind tunnel was created in order to combat the high wind areas of the project. A really good option as well for creating 3D facades to add on to existing architecture. So this project here, you've got the old riding stables down below. So the goal of the design was to create, a 3D facade inspired by piano keys. So the subframing was used in this situation to play around with the 3D elements of the facade for this project here. The option to be used on moving elements. So here you can see here the through color high density nature of the panel allows it to be used on these moving elements here. So although the facade itself is all EQUITONE, the moving elements as well is EQUITONE. And what they did here is they created some routing into the panel face in order to distinguish those as the moving areas of the building. So the opportunity to use that. We even see it used on doors as well on projects in Australia. A really good option as well for integrating concept ideas into the facade. So the project here in New Zealand, the original concept was that the existing retail, was very boring. It wasn't really enticing people to come in to see what was inside. So what the designer did in this situation is they created a custom shape within the EQUITONE panels in order to create interest to the building and to sort of give a glimpse of what's inside to make people want to enter into the building itself. You've got the design freedom as well to perforate and interact internally. So you can see here some large cutouts from the panel in order to, expose the panels behind as well. So you can see here the ability to, bring the inside out and vice versa. The ability to route or engrave panels. So we're seeing a big move for that at the moment in Australia with Indigenous engraving into facades. And this project here in Western Australia, you can see here there was wording which was engraved into the panels for the school kids as well. So you can engrave, words, patterns, various things like that as well. The high density nature of the panel just allows that to happen because it maintains itself a lot better. And the through color nature of our Tectiva panel, you can see in this picture here, just means that you've got the same color running all the way through the panel. Now, a high density through color fiber cement contains a lot of advantages over a painted medium density or a compressed fiber cement. One advantage it doesn't have is the ability to curve. Because it's a lot harder panel, it's also harder to curve. So this project in Australia, they wanted a curved facade. A full EQUITONE panel will achieve a radius of 12 meters. This project here had a radius of 4 meters. So what we did in this situation here is we had to create 400 millimeter strips to fasten it around the building in order to create that curved facade for the Taronga Zoo project. A really good option as well for difficult access areas or difficult to reach locations as well. So, by having something which requires no maintenance, so no need to paint or seal in the future, if you have got a difficult access area, where you can't get to in order to paint or seal in the future, or it might be difficult to get to paint or seal in the future, something like an EQUITONE is really really appropriate for those areas as well, because you won't need to get to it in the future to paint or seal. So really good option in that situation. Also internal high traffic applications as well. I know EQUITONE's used quite a lot internally in Australia. And because of the high density nature of the panel, it will take impact a lot better than an impact resistant plasterboard, for example. And then with our panels like our Tectiva panel, for example, which has the same color running all the way throughout, if the face does get damaged, you still have got the color running throughout the panel as well. So it sort of differs from a high impact plasterboard, which gets painted, and if the wall gets damaged, you will see that plaster behind. In Australia, we use it a lot on schools and learning centres, and the reason being is that the Department of Education, who heads up schools around Australia, really like the ability for the low maintenance nature of the panels as well. And in this image here, you can see the green panels are our Pictura from our Pictura range. So our Pictura range contains anti-graffiti as standard on the panel. So there's no need to apply a third-party anti-graffiti coating. It's on the panel already, and it's there for as long as the panel is there. So there's no need to reapply a coating as well. So they really like that factor, and they can get some pretty deep colors like reds and greens, yellows and blues. So you know, we do a lot of education projects based on that. So in terms of the fixing systems, you can see here you've got the face fixed fixing system. So the face fix, you've got two different options. You've got a color matched rivet if you're going into metal framing. So you can see the metal top hats, and then you've got the color matched rivet. Now the reason we choose a rivet as opposed to a screw is that you should never screw fibre cement into metal. And the reason being is that you don't have enough movement allowance around the screw. And what that means is in future, those areas, especially at the corners of the panels, can crack because of that lack of movement allowance, because you've got the metal top hat moving at one rate and you've got the fibre cement moving at another rate. It places great stress on the panels. So EQUITONE employs a color matched rivet, and we have got movement allowance around the fixings. So 2 fixings per panel will sit hard into the hole created, but the rest of the fixings around that panel will all have movement allowance in order to allow expansion and contraction around the fixing. So that greatly reduces the risks of cracking of the panels. Now, when it comes to timber, fibre cement has a similar movement rate to timber, so it's fine to screw fibre cement into timber. So we have got color matched screws for timber framing as well. And then we've got the concealed fix system as well. So the concealed fix system, you have got a hanger bracket, which is fixed into the back of the panel with an expanding rivet. And then that sits onto your horizontal channel. So that interlocks with your horizontal channel, which sits onto your vertical framing. So you still have got your vertical ventilated facade behind there. And then you've got your concealed, or you've got your secret fix of the panels as well. And it doesn't require any special machinery. You don't need a CNC machine like to create an undercut anchor. It can all be done on site. So it's a really intelligent system as well. You know, also what we use in Australia is it's aluminium, so it's going to be used right on waterfront, breaking surf as well. So really good option. Now, who's EQUITONE? EQUITONE's part of the ETEX group. So the ETEX group, if we think all the way back to the first slide where we had the picture of the plane, and we saw that, you know, 1903, fibre cement was invented, and 1905 goes back to when Alphonse Empsons bought the patent and when the ETEX group essentially started. With a worldwide #1 in fibre cement, with 110 plus years of experience and 40 plus years of experience in facades. So, you know, in terms of facades, it was founded for a need of a more architecturally focused panel in Germany and Belgium. And now it's spread throughout the world, where we've got probably closer to 4 million square meters of pre-finished fibre cement is sold in facades throughout the world per year. Now, if we look at the panels in the range, we've got our new panel, which is our EQUITONE Lunara. So the EQUITONE Lunara is a hammered and brushed surface finish. And then you've got the two sizes there. Our most popular finish in the range is our EQUITONE Tectiva. So it's got a sanded face, and it gives you sort of like a concrete look. The EQUITONE Linear is essentially a thicker panel, but it's routed out 2 mil, so it's a 3D looking panel. The EQUITONE Natura we saw is the oldest panel in our range back in 2004. So it's a through color fiber cement with a semi-transparent coating. And you can see there the white speckly bits, that's actually the fibers within the panel from the cellulose fiber. And then you got the EQUITONE Pictura. So the EQUITONE Pictura has a solid color. So like a painted material, that's the closest looking aesthetically to a painted material, but that's also the one with the anti-graffiti coating as standard. So it's a through color panel with a anti-graffiti coating on the surface of it, which doesn't need to be maintained. And if we look at them a bit closer, so that's your EQUITONE Lunara. So that's the hammered and brushed surface finish that we discussed. That's your EQUITONE Tectiva. So that's your sort of standard moderate looking panel. That's your EQUITONE Natura. So your EQUITONE Natura has that semi-transparent coating. This is between a sort of a matte and a satin finish. So it's sort of where the other ones are all a matte finish. This is a little bit more glossier, but it's still a very subtle satin finish, as you can see. The EQUITONE Linear. So you can see the 3D panel with the high and low spots. So really good for feature areas of projects as well, where you're trying to make a feature of the facade. And the EQUITONE Pictura. So you can see here one of the projects in Sydney where it was used on the school project. So you can see there the bright colors that you can achieve with the EQUITONE Pictura. So yeah, our panels are through color and high density. You can see there they're made from sustainable materials or sustainable use of the panels. So the ability to reuse the facade in the future, or to crush up and use as gravel. You've got different textures and expressive surfaces as well. So looking at the range, you can use all 5 panels on the one plane if you want to create something really individually. Low maintenance. You've got 60 different colors in 5 different ranges. And EQUITONE is also designed by architects for architects. So we're heavily involved in focus groups all around the world with different architects for new colors, new finishes. So yeah, basically we don't just manufacture panels and say, here, use them. We actually get involved in finding out what the needs are and things like that as well. Now your sales team as well. So you have got Willem, Mehdi and Stanley, and also Amazon as well. So they'll be able to help you out with anything that you need. Also assist with your project, or as little as provide samples as well. So definitely available to assist you. Does anyone have any questions?
There have been a few questions in the meeting chat box, but Amar has been on top of them and answered quite a few of them. So thank you, Amar.
Thank you.
Sorry, go ahead, Mark.
No, Shandi, I was going to say no. If no one had questions, I'll let you finish it off.
We had one more question from Joseph. Oh, Amar has also answered that now. Thanks, Amar.
Thank you.
I think that might be it. Thanks, Mark.
No, thank you. Thank you everyone for attending. I really appreciate that. Hopefully, you've learned something today. We're definitely there to assist what you might have. Yeah. And did you want to mention anything, Shanti, before we signed off?
Sure. So thank you again, as Mark said, to everyone for attending. If you do have any questions, please feel free to contact Stanley, who is here on this chat, and he'll be able to answer any of your questions, or whether you'd like a copy of the presentation, we can also help you with that as well. Okay, thanks everyone.
Thank you all. Have a great day.